Here's a cool map that shows the various paths of hurricanes in both the northern and southern hemisphere. Some things to note is in the northern hemisphere, all of the hurricanes deflect to the right, Coriolis effect. When we look at the southern hemisphere, they all, for the most part, deflect to the left. Another thing you'll note is that red line indicates the equator. And so you never, ever, ever see a hurricane crossing the equator. And this goes back to, once again, when I talked about the doldrums, converging air. You're not going to get air, in this case hurricanes, to be able to scoot through the equatorial low pressure trough because of that convergence. And we can see the hurricane paths in the northern hemisphere, they curve to the right, but we have a specific period, June to November. And this makes sense. Once again, water takes longer to heat up, but also takes longer to cool down. And so actually the waters in our beaches there in Florida and Texas are actually their warmest in September, in October. And so you can note this actually if you go to the beach for spring break, you notice the water's kind of cold. But if you go to the beach during fall break, it's actually going to be warmer there in September and October. And key to understanding that, like I said, is land-water heating differences. Of course, everything is the opposite in the southern hemisphere. And so when we think about these hurricanes that hit the southeast United States and the Caribbean, what happens is they come off of the July intertropical convergence. So they come off of that equatorial low pressure trough. Once the hurricanes move through the subtropical high pressure, they then get carried by the mid-latitudes and the westerlies that then causes that even more of a right-hand bend. And so oftentimes we can see hurricanes coming through the Gulf and the Atlantic and hitting the southeast United States, but oftentimes they come up and then eventually the westerlies carry them up towards the northeast coast of the United States to New England and then eventually carries them back out to the North Atlantic. Of course, hurricanes, as examples of low pressures, are going to also have a counterclockwise spin in the northern hemisphere and a clockwise spin in the southern hemisphere. So just by looking at this hurricane here, we can identify that this is in the northern hemisphere. So which hemisphere is this hurricane located? Several key concerns to note when a hurricane makes landfall. Of course, the powerful winds. And if you've ever observed a weather person standing on a beach about to get blown over, you know that you can attest to those powerful winds. The powerful winds are going to be their most dangerous or the strongest in the right front quadrant of a hurricane. And I'll show this here in a minute. Further, often people don't realize, but further inland, so most people think that just at the shoreline, just at the coastline is where the damage is done, but further inland, oftentimes tornadoes are spawned, so you have another type of a severe weather event that occurs associated with a hurricane. Further, storm surge. Storm surge is overwhelmingly important when we try to understand why Hurricane Katrina was so deadly. And so storm surges are the ones that actually do the most amount of damage. It's not the powerful winds. It's not the fact that people get hit in the head by debris. Instead, it's the fact that people are actually drowning from the surge, the offshore rise in water that's caused by a hurricane. So we're going to focus in on all of these key characteristics of a hurricane when making landfall when we try to understand Hurricane Katrina right now. So let's apply all these concepts to Hurricane Katrina. Like most hurricanes in the northern hemisphere in the Atlantic Ocean, they originate off the coast of Africa. And so these low-pressure centers originate actually there in the equatorial low-pressure trough that we find there just south of that persistent dominant high pressure that we find over the Sahara Desert. This, combined with the upper-level winds, plays a key role in understanding the general bend to the right of hurricanes in the United States. And so one of the characteristics of sometimes with hurricanes is the fact that as this hurricane spins, counterclockwise keep in mind, the upper level winds do a good job of protecting the interior, or essentially New Orleans in this case of Hurricane Katrina, from hurricanes approaching. Now we see a much different situation. Once again, the upper level winds, the jet stream, they meander, and so we can have a different meander in which now, in this case, this low pressure, extreme low pressure hurricane can actually penetrate a little bit deeper, and once it penetrates a little deeper, it then can go over the extremely warm waters of the Gulf of Mexico. The waters of the Gulf of Mexico are extremely warm because they're shallower than the deeper waters of the Atlantic Ocean. And so the shallow end of the pool, as you note, in the summertime is going to be warmer than the deeper end. And so as that hurricane then now comes over into the Gulf of Mexico, it essentially becomes even more intense, which is a key to understanding Hurricane Katrina. Here's the general path of Hurricane Katrina. So it originated, became a hurricane over the Bahamas, worked its way towards the Atlantic side of Florida. However, then because the upper level winds moved, it then allowed it to be penetrated deeper into the Gulf of Mexico, where it then went over the Everglades, which is essentially warm water that's on the surface, which, although it's land, is quite warm and wet, which helped to intensify the hurricane. But then once it got over the very shallow, comparatively, waters of the Gulf of Mexico, it really intensified, showcased by that red color, which is measuring strength. So the red color illustrates the strongest point of this hurricane. Here we can see the massive size of Hurricane Katrina, and so you can see to the left of the eye, Louisiana, to the north, Mississippi, and to the right, Alabama and Florida. And so deep within Alabama and Georgia, and even in Tennessee, as the Hurricane Katrina was making the eye of it was making landfall there in the southern part of this map, to the north, there actually were tornadoes being spawned in those dense rain bands that were found further away from the eye. This illustrates, as we zoom into Hurricane Katrina and zoom into the eye, this illustrates the right front quadrant in which the winds were the most severe. If we look to the left front quadrant is where we'll find New Orleans. And so actually New Orleans didn't have the most intense amount of wind when the hurricane came through. So the winds were the strongest actually over there in Mississippi and close to Mobile, Alabama in the right front quadrant of Hurricane Katrina. Here's an image that showcases a storm surge in which the normal tide is far surpassed by the surge created by this low pressure that's bringing with it a ton of amount of water that is then going to of course, flood areas that are just above mean sea level. This here is absolutely critical for explaining why Hurricane Katrina was so deadly, what created that storm surge. Here we have an interesting situation where New Orleans is actually on the southern side of Lake Pontchartrain. And so this is kind of a lake, but it's kind of a mix between an ocean and a freshwater lake. It's what we call brackish water. And one of the things, if you note, that line coming from north to south through Lake Pontchartrain, that's about a 35-minute long trip across that road, showcasing how big this lake is. But New Orleans is found on the southern side of this lake. So if I put this hurricane in motion, what happened is the eye actually was just east of New Orleans, which is the worst case scenario for New Orleans. They would actually be better off if that eye went directly over New Orleans instead of just to the east. Because if we look at this arrow here, what happened is the storm surge from actually Lake Pontchartrain is what flooded all of New Orleans, or much of New Orleans. And so the low-lying areas of New Orleans were the first places to fill. And so one of the things is this eye being to the east of New Orleans then brought with it, because of that counterclockwise spin, brought with it the water from the northern part of New Orleans, the Lake Pontchartrain storm surge, which then flooded the low-lying areas. And if you know anything about New Orleans, it's essentially under seawater and under sea level. But also the lower income individuals tend to live at the bottom of the bowls, and so the lower level areas where the few highland areas is where the wealthy people live. And so go figure who are those that were most influenced by the storm surge. That would be the lower income individuals. Here's a Doppler image that shows the arrival of Hurricane Katrina, and we can see those dense rain bands. Before the hurricane even made contact, the eye made contact with the shore, we could see those dense rain bands leaving their effect. But the hurricane went just to the right, or to the east of that star, and that star being New Orleans. And so the storm surge was really bad for the delta area of Louisiana, but also for Mississippi. It was really, really bad. The red area illustrating where that storm surge really was the most intense. And this is just to the east of Louisiana. And so what this is showing is the storm surge where it was the most severe was actually to the right, or the east of New Orleans there in Mississippi, the little sliver of Mississippi that has access to the Gulf of Mexico. Here's a recent map that shows from The Economist, shows the most expensive hurricanes in the United States, and they actually are increasing. This goes along with what I said beforehand, where weather-related damage is increasing. So actually Irene, although only had 40 deaths, some have speculated that it's actually the most expensive of all hurricanes because it hit such a high populated area there along the East Coast. But nonetheless, we can see the general right-hand bend of all these hurricanes, the most severe ones and deadly and expensive in the United States in this map here.